So this is actually called like a meme-filled introduction to bonding curves, because I love memes and these are some memes. So just so I can get sort of lay of the land with everyone, who here thinks they understand blockchain technology? Put your hand up. Yeah? Okay, cool. Who here thinks, identifies as a developer? Cool. And who here thinks they understand bonding curves or has some good knowledge of bonding curves? Yeah? Some people, okay.
Are you going to ask questions?
So there's a lot of content. Sort of the way I like to do it is a bit interactive. So, you know, I'll be looking at you, and if you're nodding, I'll be like, okay, I'll keep moving along. If you have a confused look on your face, then I'll slow it down. If you're just staring at me, I can't read that. So try and give me some.
And if I'm like this dog, we'll do it.
Sorry?
If my face will be like this dog, we'll do it.
Then it means you're excited. You're such whales. Right?
Okay.
It's much romantic is because it's Valentine's Day, so happy Valentine's Day. Okay, so a bit about me. So sort of the crypto background. So in 2014 I got into Ethereum. That was when they first started. I was in the Valley and my friend told me about this amazing thing that was programmatic money, and that was Ethereum. And I got excited about that. In 2015, joined Coinbase as an analyst with me and my wife, actually. So we were working remotely, traveling the world. That was quite fun. 2016, I was part of the team that contributed to the first version of the Coinbase app. That was when Coinbase had one other mobile developer. So we tripled their team, mobile team, with the two of us. And then 2017, I was sort of the crypto investor. We made quite a lot of investments in the crypto space. But then in 2018, we decided that we didn't really like that much anymore. We decided to focus on building. And our main projects at the moment are Kana, that one, Kana.io, which is about dynamic bonding curves, which I'll go to towards the end of the presentation, and then Amsterdam, which is another meetup more focused on makers in the blockchain space. And 2019, probably more the same. So, WDF, bonding curves. Does anyone want to try to explain what they think it is? Anyone want to be brave? No? Okay.
Yeah, well, that's great.
So,
Let's not do that.
this is a very basic representation of a bonding curve. You see up here? So this bonding curve is basically, well, it's a basic graph, quadratic graph, and it moves up the y-axis according to this formula, which basically says the current price, so the y-axis, is equal to the token supply squared. So for whatever value we have here, we square it, then that leads to here, and that will be the price. Right? So the point of this is that the price moves up and down based on certain actions that people take. And I'll go through an example using the same formula of the sort of basic curve. We have here Alice and Bob, and it's a contract. And let's say we have a token supply, so the smart contract begins with just 10 tokens, and there's $100 backing the curve. And that's, when we say backing the curve, we basically mean it's collateral backing the curve, and there's 10 tokens in existence. So if Alice buys $100, or sends $100 to the contract, that means the price per token is 10. So there's 10 tokens, we square that, it equals $100. Does that make sense? So it costs her $100 to get one token. Making sense? Yeah?
Yes.
Some confused looks. I can go through it again. Do I need to go through it again? Was that? No? Okay, keep going. And so now, since she's received one token, we've added a token to the supply. So now we square that. Now the new price is $121. Now Bob comes along, he has $100, he sends it to the contract. He receives 0.826 tokens because now the price is higher, so he doesn't receive one whole token, he receives a fraction of the token. And then in summary, the token supply, so the total amount of tokens in existence, is 11.82, and the total backing funds, or the total collateral in the pool, is $300. Okay? So that's sort of the first part, and that's when you're buying in and how the price, that's basically the price moving up the graph, right? Because people are buying, the token supply is expanding, and there's more collateral backing the curve. Next, what happens when people start selling? Right, so if you sell Alice sells 1 token to the contract, therefore we get a total token supply, we square it, that means it's $139 per token. So she receives 139, so she makes a little bit of a profit straight away she bought originally for $100, now she gets 139 back. Now the token, because the token, when she sells it, the token is basically burnt. So now there's only 10.82 left, we square that, that's the new price. Bob sells his token. Unfortunately, he loses out a bit, he gets $96 back instead of $100. So now in summary, total token supply is back to what it was, 10, and the total backing funds is $63 remaining in the pool. Right, so that's a really basic sort of bonding curve as an example. And I guess the main point to understand from that example is that as people buy in more, and that mints tokens, and then so we start increasing the token supply, and that means the price goes up, right? And as people sell the tokens or burn the tokens to the contract, the price goes down. So you eventually should have some sort of equilibrium based on the activity between the contract. Some people will think that down here it's worth a lot more, so they'll buy a lot, and they'll in turn push up the price. Some people think that's overpriced up here, they'll sell it, then it'll pull down the price. So with this graph, we're saying there's one sell, one buy price, but you don't have to do that. That's the amazing thing with smart contracts and developing contracts, right? You can have different, what we call ceilings and floors. So in this case, we have the same graph, exponential graph, but we can say that you buy in at a certain price, but if you sell, it's actually a lower price, right? So that can incentivize people holding the tokens for longer, because maybe you don't want them to sell straight away, like in Alice's case, right? So this means if you buy in here, and if you want to make a profit, you have to wait until the token supply is around here to sell to actually make a profit. And this applies to other sort of functions as well in the graph. So this is a linear chart, the same thing, we have different ceilings and floors. And then also you can have rule-based functions. So basically you can design the entire bonding curve however you want. In this case, they said, we want the token to appreciate by 25% for every doubling of the number of tokens issued. Right? And you get a really cool curve like this, and you're basically designing the whole crypto economic system however you want it to be. This is another interesting one, Sigmoid Function. So what this basically means is that if you want the price to remain stable, or be really low at the start because you want to get early adopters, and then as the general consumer comes on board, you want sort of an exponential growth of the price, and then when it's matured, you want the price to stabilize, maybe like turn into a stable coin, you can actually design that into the curve. And that becomes really interesting. I'll give a real world example a bit later of that. Any questions so far on that? So you can see that there's different functions, different mathematics. You can design the curve however you want, depending on what you want to incentivize. Another one is a sponsored burn. So let's say if Blockchain Talks had a bonding curve that they were using, let's say ABN, the bank, could say, hey, we want to do a sponsored burn. So what that means is they can send money into the bonding curve, but not receive the tokens back. So that means however much you bought in for, you're sort of mostly guaranteed to make a profit, because basically they've sponsored the curve. So they've just increased the collateral without taking tokens out. Right? So a lot of this information, it's like general information, it's theoretical and things like that, right? So what are the use cases for this? And Jana mentioned Bancor. So Bancor, who here knows what Bancor is? Yep, okay, cool, awesome. If you don't, it's basically a automated market maker. So instead of going to an exchange, doing KYC, all that stuff, you can just interact with a smart contract, and the price is based on the bonding curve, right? So you buy and sell however you want. This is their mathematical proof, which is really interesting. So the thing about Bancor is, like Jana said, they did some really important work in this space, in that they were the first ones in production, and it's working really well at the moment. And the example that I gave of Alice and Bob before, that was a really simplified example of what we call a spot price. But realistically, you don't do a spot price, because each purchase, if you buy 10 tokens, each fraction of the token that you buy should push the price up a little bit, right? It shouldn't be a spot price. So in production, what you do is you find an integral of a function, which Jana is really good at, okay? And you calculate the area under the curve, right? And the area under the curve determines the price for tokens. So, you know, if you want to do it properly with Alice and Bob, you'd do sort of a much more complex calculation. We have another one, Ocean Protocol. So Ocean Protocol, I think they're based out in Berlin, and they're like an AI platform dealing with data sets. And one of the problems with AI is getting good data sets, because you're essentially training artificial intelligence with a lot of training data. But how do you know the data that you're putting in to the system is actually worth it and valuable? So what they do is they have a bonding curve for each data set. And if you know that this data set is really useful, you can buy that token in that data set while the price is sort of static here. Right? And as more people buy in, the price of that data set goes up. But at the same time, that indicates that a lot of people have faith in this data set, that it's actually useful. So for example, it might be a government agency releases a data set. Then we know that a government agency, that data set is really high quality, so you know, people will jump in, price goes up, you know, there's ways you can profit as well. But the main thing about this is that we essentially start curating information. So that goes to the next topic. I'm going to keep moving forward if no one stops me, because it's going down a winding hole now. So that's where we get to TCRs, token curated registries. So when you think of token curated registries and crypto economics and crypto primitives, you can start with bonding curves, they're sort of at the bottom, and then token curated registries, or also known as curation markets, they sort of come out from bonding curves, right? So token curated registries, essentially we curate a list in a decentralized way, in a trustless way, and we use economic incentives. So for example, if we have these excellent memes, right, and maybe I think that this meme is really cool, and I think it'll be really popular in the future, but maybe Jana thinks that she likes this meme, and she thinks this one's really popular, and maybe we'll do something like a competition. So, okay, the one that reaches the front page of Reddit will win a prize in a certain pot. Then what we can do is essentially we can send this out to the market, and if you're really good at determining what goes well on Reddit, you can like buy tokens in this meme, right, which pushes the price up, and that sort of indicates, okay, which meme would be more popular. Does that make sense? Sort of? So this sounds a bit crazy and funny, but it's a real use case. So a company or group called District 0x, they have a project called Meme Factory, and that's what they're doing, TCR for memes. But it's not just for memes. We can talk about any sort of list, right? So the best restaurants in Amsterdam, the best wines in the world, right? We can create a token curated registry where people are economically incentivized to create a list that is inherently correct, right? Because they have an economic stake in it, and you have opposite forces that if they disagree with you, they can make money from you. So that's bonding curves, token curated registries, and then what other people are doing as well is, you know, in the crypto sphere, you have a lot of different crypto primitives. So what we can do is we can combine them. So one of the things we can do is we can combine them with things like NFTs. And some people really like NFTs. So there's a company out of Switzerland, South Africa, by this group called Linear Labs, which are doing really great work in bonding curves. And their company is Molecule. So what they're doing is funding potentially world-changing drugs. They combine NFTs, funding TCR, and token bonding curves. So their use case is pretty cool. So let's say you're a scientist and you have an idea for a cancer-causing drug, but you have no money, right? You create a bond, you have a bonding curve, and essentially at the beginning you get like a creator stake. So you get a bunch of tokens that are worth nothing, right? And then you start putting out research, you start putting out, you know, all these things that, hey, this is why I can do this, and this is why it's a cure for cancer. And the people that believe you or look into your work, they can start buying tokens of that, right, of what you're building. Then essentially, eventually it goes up, then remember this is a curve, right? So it doesn't keep, this x-axis is not a time axis, so it's not guaranteed to go up. It can always go backwards as well. So let's say you're doing a cancer research, then people find out you're a scammer, then they start selling, then essentially the token's price goes down, then the creator stake is worth nothing. Right? So this is a really cool model in that it aligns creator or inventors' incentives with the funding bodies as well. And then what they're doing is they're putting that whole bonding curve into an NFT, and an NFT represents a molecule. Right? So if you wrap your head around that, that's pretty cool, because then essentially you can own like a bit of an NFT, and this NFT can be a patent, right? And then maybe the payouts that goes in patent get distributed as collateral to the bonding curve, and then that's how you can have sort of a much more utopian way of funding drugs and drug research. Another one is AdChain. So AdChain are doing a TCR as well. So Google and Facebook. Yep.
One back then. So the person with a possible cure for the disease.
Yep.
Also holds tokens in or herself then here, or?
Yeah, exactly. So they will get the creator stake
Okay.
when it's worth nothing, right? So they're basically saying, hey, I want to do this work, and I get a certain percentage of tokens, but there's nothing. There's no worth there.
And like the rest are for sale as an investment in the project.
Yeah. So maybe this is day zero, and if you buy it right, like maybe because this is not a time scale. So this time here could be 1 day, or it could be 1 year. So it could be, a cent.
It's basically the investment period allowing project.
Yeah, so depending on the project.
Yeah.
I mean, this is in a general sense. I'm not sure how Molecule is doing exactly, but that's how I think about it, right? It depends on how they increase the supply. So are they minting tokens every week, or are they doing it based on you just send money, how many tokens are they minting, things like that.
And it went a bit fast with the NFT. How did it connect to this?
Yeah, so at the moment, let me think. So if you replace this with a CryptoKitty,
Yeah.
right, and the CryptoKitty sells for like $10 million, right, that's cool, and that goes to like one person. But what if I think about memes, right, and I'm like, okay, this CryptoKitty is really special, right, then we're going to back it, essentially we're going to make a bonding curve own that CryptoKitty, right, and only one person can really own that CryptoKitty at a time, right, so then now we say, okay, the smart contract owns the CryptoKitty, and then anyone can buy in to this bonding curve to own a piece of it, essentially, right? So then you can buy in to this, and then maybe it gets really popular, and then later on the CryptoKitty gets sold,
Yeah.
and then that gets distributed to the token holders.
So the NFT represents the ID to cure the disease.
Yeah, exactly. In this case, yeah, exactly. The NFT is the cure or the IP. So think of it as a patent.
It's a patent number.
Yeah, exactly. So going to the AdChain, so AdChain is Facebook and Google, they have this massive problem. They spend billions of dollars a year on fraudulent advertising. That just basically means there's landing pages full of adverts, and there's just click farms, and people make money that way. So AdChain's trying to solve that problem. They're using TCRs on both sides. So on one side, saying, hey, NewYorkTimes.com is a pretty good site, it's legitimate, it's real traffic, so the ads on that site are good. And then on the other side, they also have I think advertisers as well. I don't think it shows it in this graph, but they also have these are legitimate advertisers, and they're advertising correctly, and they have this whole ecosystem around that. And I think they're in production at the moment. I'm not sure how adoption is going yet though. But wait, there's more. So the convergent, this is the new one as well, which I think is quite interesting. So they're doing personal tokens. So let's say if for me, myself, I was just starting my career, then I can say, hey, I'm going to put a bonding curve for my own career. So hey, you can buy tokens in me right now, and I get to take that money, and I give you tokens in return. And I can say, hey, in the future, in 1 year, it's going to be worth 1 hour of my time. Or you can redeem it for some product that I'm creating. So I can create a little mini economy around myself. And the interesting part here is what they're doing. They have a different buy and sell curve, and there's a spread. So basically, if you buy $100 worth, and that goes into the reserve, let's say $50 might go into the reserve, and there might be a $50 spread between the sell and buy, and that $50 spread is what I can use to pay for my education or to do whatever, right? So then you can always have this money back in the curve where if you get sick of me, then you can just sell your tokens, and other people can buy it. But then I'll always have sort of this spread that I can use as a salary, essentially. So I think that's quite exciting because it sort of rethinks, how do creators or creatives, live in the world? How do they, do their work? If you think you found the next Beethoven or Van Gogh, maybe this is a new model for them. Another interesting one coming out of the US is relevant. So one of the big problems with news is the algorithms base it mostly on clicks. So then places like BuzzFeed, they optimize the headlines and say like, you won't believe what this person did, right? And that's like people will click on it, and that's how they make the advertising dollars. With relevant, what they're doing is basically putting it behind making a TCR, as far as I understand, with bonding curves. So you can buy or basically stake your reputation on certain stories and saying this story is of really high quality, and the more people that sort of put their reputation behind that story, the more popular it goes, and that's how the algorithm works. So it's really opposite from optimizing for clicks, and they're optimizing for actual relevant and worthwhile content. Okay, so far is it making sense? Sort of? At least you're getting some bits and pieces? Okay, so we're just going to go deeper into the rabbit hole now. So bonding curves, so far what I've talked about is they're generally 2D, right? But they can be multifaceted because it's mathematics. Right? So at the moment what I've been talking about, it's sort of like Mario in 2D, it's a bit pixelated. But what's possible is actually we can do like a 3D or 4D or 5D sort of Mario. And that's where I think a lot of the exciting opportunities come. So here, this is a 2D graph. Here, this is a 3D graph, right? And I can't represent a 4D or 5D graph, but you can do it in mathematics, right? When you start working in sort of these 3D spaces, it becomes quite interesting in that you can have other factors affecting the price. So instead of just being the token supply, it can be maybe depends how the weather's going, or how the GDP of the country's going, or depends on your contributions. Yeah.
This is also getting too complicated.
It's all good. It's right. So you can actually include other factors to influence the token price. Right? And that's where dynamic bonding curves come to play. So over the last few months I've been doing some research and things in sort of this bonding curve space and working with multi-dimensional bonding curves. And the best way to describe a dynamic bonding curve is to talk about a use case that we're applying to, and that's in a project we call Kana. And that's a way for communities to incentivize certain behaviors. So how do you incentivize people to contribute more to the community? How do you incentivize them to come to free events and things like that? And how do you penalize freeloaders? So people that come and take, but then they don't contribute anything. Right? And this is a normal graph. The current price is based on the token supply, as I said before. However, the thing with this is that no matter who you are, everyone gets the same price. Right? And then with dynamic bonding curves, what we can do is we can include a factor that is based on something about yourself. So in the case of Kana, what we're doing is including basically the portion of the supply that you own. So if you own a large amount of supply, then your tokens will be worth more. If you own a low amount of supply, then they'll be worth less. And here's some examples. Yeah, so I'm losing a few, but that's all right. I'll keep going. We're nearly home. All right. So this is the first example of a dynamic bonding curve. So let's say person A. This is a time axis now. So at the start, you can have someone that contributes a lot, right? Maybe we help organize an event, you volunteer your time, you contribute a lot, you make the events or the community really valuable in a certain way. So you earn a lot of tokens here, but over time, maybe you decide you don't want to contribute anymore, or you move countries or something, right? So your portion of supply starts to reduce over time. And as a result, the price of your tokens also reduce as a result. Right? This is another case of someone that gets progressively more excited about the community. So they find out about it, they contribute a little bit, and they just keep contributing more, and eventually they own quite a large portion of the supply. And in this case, the more they earn, then the more they own. And this is more of a realistic scenario in that we have a person that comes and goes, sometimes contributes, then gets busy with their life, but then comes back and then starts contributing again. So this is what we envision will be the more usual case, in that the price will fluctuate depending on that person's contributions. And it's okay if you go on a holiday for like a year, you can come back, you can start contributing again to the community, and you'll still capture some of that value that you've put into the community.
Tamagotchi curve.
Sorry?
Tamagotchi curve.
Yeah, maybe. So this is combining all the graphs. The more important part here is this purple bit. So the amount of funds backing the dynamic bonding curve theoretically could increase. So that means that the collateral can increase. So let's say as the community grows, it gets more funds or more collateral sent to the curve. And that means that even if you have a huge portion of the supply at the start here, they're worth nothing because there's nothing backing the curve. But then, over time, the tokens are actually worth more than they were back here because the purple area has increased. Right? So this incentivizes very certain behavior, and that's sort of what's exciting about dynamic bonding curves, in my opinion. So in summary, if you contribute early and often, that's very, very valuable to the community. If you contribute often, that's high value. You do it occasionally, there's some value, rarely small value, and if you never contribute, you have no value and you capture no value from the community. And I think, in a sense, this becomes a much more fairer system when we start talking about how to incentivize, reward, engage certain behaviors. And then just quickly, some other use cases of dynamic bonding curves. This is a picture of future, because this is the future stuff. So besides communities, there's like product development and bounty allocations. So I think we had like 2 or 3 developers in the room. So for example, let's say if you had a product you're building, but maybe the portion of the product that you're building is actually 90% of what captures the value. In this case, we could reward your contribution to that project much more accurately than just getting a straight salary, and maybe the person sitting next to you is getting the same salary. He worked on a smaller, less impactful portion. We can do bonded donations, so this is another related project to Kana, and essentially we can determine who has helped the charity create a viral cause the most. So who's spread the message of the charitable cause, and that becomes really quite interesting as well, because in the modelling there's a point where you can potentially make a profit on the donation that you make to the charitable cause, which brings up other interesting discussion points as well. And then also governance. So there's a lot of talk about DAOs and things like that these days, but the problem with a lot of governance processes is active participation. And if someone's really contributing and participating and wants to have a say in the community, there's no real way of them indicating objectively that, hey, look how much I've contributed, look how much I care. So I think this is also an interesting use case. So that's my talk. That's my handles on Twitter and Telegram and whatever. So feel free to reach out. And these are sort of the projects. So, any questions? No questions? Yeah, that's good. Everyone understood. Very good. Yep.
Is the token in U available, so that I don't have to understand everything? I could just give you €100 and then profit from all the results you will create with thinking?
So, in me personally, not at the moment, but so Convergent is a project that's trying to do that. I think they're starting with creative people. But yeah, I think easily, this is all open source work as well, so anyone that can hire a developer or developer can make it themselves as well. So that's definitely possible now. Yep.
About the Kana project, so how do you see users of the project? Is it something for programmers to integrate, or is it for end users to interact somehow with and apply in day-to-day life?
Yeah, at the moment, it's the users are mainly community leaders, because Kana itself is more focused on community incentivization. So the community leaders would give out tokens and incentivize certain behaviours. And then maybe you as a community member, you'd receive these tokens, and there'll be certain ways for you to redeem value, whether it's you get to sell them to the curve to take some money out, or maybe you get invited to a special dinner that's exclusive for the top contributors of the community, or things like that, right? Yep, at the back.
Yeah, you're probably not an expert. Can you maybe, as far as I understand, you apply this business model on memes. Can you maybe say something about what your experience are of the business model in practice, please?
Yes, so some of the examples I gave, it wasn't just memes, but it was like Bancor. So that's like a real business model. They're quite a successful project, Ocean Protocol. But Bancor is probably the furthest in production. That's like a real company making money and things like that. So with Bancor, there's another one, a new one, open source project called Uniswap, and that's similar to Bancor in that you're creating exchanges that are encapsulated in just a smart contract. So you can just deploy this contract, and then you can take a fee off the top of any sort of exchanges that happen within that smart contract. So there's a lot of interesting sort of business models that come out of this.
Okay, it's
Okay.
pretty much.
Okay.